So you are welcome to the class. So we're presenting to you machine learning for improved healthcare delivery. So taking clue from the past successful applications while exploring the present and future possibilities. Speaking with you, Professor Adam Olatunji. So we show all the best and you're welcome to the presentation. Now, so starting with the preamble and the agenda of the presentation. Preamble and agenda of the presentation. So when we say machine learning, so especially we're going to talk more on machine learning, so we talk generally on AI. So as the topic shows, we're looking at machine learning for improved healthcare delivery. But we cannot talk of machine learning without mentioning the artificial intelligence, where it comes from. If you can look in the part of our preamble, if you look at the screen, you can see a very unique picture. So, and showing the timeline. This is what we used to have in 2009, not long ago, maybe just a decade ago. And by 2019, this has taken over from this. So when you want to take aerial photography of a particular occasion or videoing some things from the space, so you have to use a helicopter. You can see that. Pictures speak louder. However, these days, starting from 2019, people will prefer to use this because doing this is very risky to the life. This person is risking his life. Anything can happen. You see, at the end of the day, he might still not be able to cover it as a drone will do. So with the coming of artificial intelligence, things are getting easier. So you can take even better picture, better photography than what this man will do. But the risk here is almost zero now. At zero risk, no risk. As the video is being covered, the drone is dropping it in a remote storage location. So even if something happened and the drone is gone or got damaged, you still get your recording. However, if anything happens to this scene, both the person who is doing the photography and the recording might be gone. So you can see there's a very big improvement opportunity created in the development of artificial intelligence, because this is made possible. This is what we call robots, which is an aspect of artificial intelligence, AI. So when you make machine being intelligent to be able to do some things that usually human beings are the one that are known to be able to do it. And now AI does not just do that, but doing it better in a better way with safety and without risk attached to that. And that is the reality of the world we are now living in. So for people doing this kind of job, now they have to start thinking of, okay, how can I upgrade? How can I upgrade? So you need to upgrade so that you'll be able to use to program drone because of his experience in this field. He can then go into programming drone to take the same photography he used to take using a helicopter. Is it the cost we want to talk about here? The cost of hiring an helicopter that is going to be used for this? So, and so many other things that is involved. But with a very small drone, you can do the task better and safer. So this is what artificial intelligence is bringing to the world. You see, safety, improve service delivery in also of other areas. So, but today we want to look at from medical point of view, public health delivery. How can we take advantage of this unique capability? Of course, not to replace medical personnel, but how can we really make it possible for AI to support us, to aid us in achieving effective medical delivery and related stuff. So this is a general overview of artificial intelligence, briefly. The artificial intelligence is under preamble, is mimicking the intelligence or behavioral pattern of human. Artificial intelligence is a word coined from, two words combined together. Intelligence, we all know the meaning of intelligence. Then artificial. Artificial means man-made. Man-made. It's not original. It's not the natural one. There's the natural intelligence that Allah Azza created in us, that God has provided for human beings. So we have intelligence at different levels. However, when you call artificial intelligence, when you try to make machine to also have some form of intelligence closer or similar to what human beings do have. The human intelligence could be referred to as natural intelligence. However, this is artificial, something that is opposite to natural. We call it man-made. So it's made by the artificial intelligence engineers who will program like a robot. We just show here, program a robot to fly and then be able to take pictures, to take videos, and be able to know when to land and where to land. These are form of intelligence that ordinarily human beings are the ones that are noted to do that. So under this artificial intelligence, it has subfields, broad subfields. Among them, we have the robotics, which is in charge of where we produce things like drones, robots, and hosts of other systems that behave that like human beings. They can walk, sometimes they can talk, they can, yeah. However, we also have like NLP, natural language processing. So it's another very big area of artificial intelligence. We have knowledge, we have what we call knowledge-based system or expert system. However, machine learning also is one of those subfields of AI. However, machine learning, it is a technique by which a computer can learn from data without using a complex set of different rules. It's mainly based on training a model from using the data set. So why machine learning is very unique among the artificial intelligence fields will be explained to us in this presentation. So it was really unique, and today when you mention AI, people are getting confused with machine learning because everywhere it is machine learning. Everywhere it is machine learning. Why? Do we only have machine learning as the field of AI? No. However, machine learning is unique in the sense that other areas of artificial intelligence, they also need machine learning if they have to really perform in a very unique way. For example, to have a robotics that can do unique stuffs beyond just ordinary programming, it needs machine learning. For NLP, like the language model that we are now talking about, that you can conversate with, you can ask questions from it, it's a build of machine learning. So NLP, they need machine learning. Robotics, they need machine learning. It means other aspects of artificial intelligence, directly or indirectly, depends on machine learning to be able to have a sophisticated performance that is envisaged to revolutionize the world. So under this machine learning, we have another subfield, which is deep learning. That's, see, it's a form of machine learning, but however, inspired by the way our brain functions, it is the neural network that is taken to higher level. And it's often very powerful when you have to use for image processing or video processing and so on. We're going to come back to that. So these are very, very unique ones. We have the big boss, the artificial intelligence. Then we have machine learning, under which we also have deep learning. So as the video actually showed. So that is just making a preamble to what we want to say. Now for the agenda of the day. So we're going to have the preamble, the introduction to machine learning, successful application domains that have been explored earlier. And then we are more concerned with applications that are related to biomedical and public health. We're going to show us some samples, then ongoing effort and future possibilities. So what are the other possible areas to look into? And then we're going to look into the challenges of implementing artificial intelligence or machine learning, to be specific, in the area of public health and other biomedical applications, the future trend, and also the conclusion. Now, we start by introducing machine learning to us. So what is machine learning? See, Before we go into the definition of machine learning, let's look at few quotations about machine learning. Bill Gates, the popular former chairman of Microsoft, used to say that a breakthrough in machine learning will be worth 10 Microsofts. That is, a single breakthrough in machine learning will be worth 10 Microsofts. That was then. I know now if he has to make a statement, he makes something even more. Because I can say it's worth thousands of Microsofts, if not millions of Microsofts. Because, however, the one that's, I think can summarize whatever quotation we've ever had about it is what I just highlighted here. Machine learning is the next internet. This was by Tony Tita, the former director of DARPA. Machine learning is the next internet. This, from my experience, really summarizes what is which we expect of machine learning and what is already happening. Machine learning is the next internet. What is the meaning of this quote? The meaning is that you are no internet. Internet came and changed the way we do virtually everything. Internet revolutionized the way we communicate. Now you can be here, something might happen in the next street. Your family member who is outside the country presently might get information before that you are actually within the system, before you get to know about the incident because of communication, internet. Maybe somebody posted immediately online, then it will call you, hey, what is happening there? That is internet. Before you write letter, you post the letter, gone are the days. Just chat. Somebody elsewhere, you're already communicating. Even look at our discussion today. So we are communicating because of the presence of internet. That's why I'm able to teach you now online, and you can listen to me. We can even visualize, we can do whatever we want to do while communicating through the internet. What of our banking system? Internet changed the way we bank. See, in those days, you go to the bank, you have a lot of customer service, you have a lot of teller guys who will be collecting your money, giving you your money. But today, you might not even need to visit your bank in a year because everything is done through online. You get online transfer, you get your money through the ATM, whatever you want to do. Even to get your ATM card now, you just go to your bank and print it out. You don't need to see anybody. The ATM machine, we print it out for you. Talk of anything you do, internet has changed the way we do things. That is internet. So now, when somebody now defines machine learning that it is the next internet, that is, the meaning of this quote is that the next thing that is expected to change the world the way internet did is nothing but machine learning. And we're already witnessing it now. It's already everywhere. Just like internet changed the way we do things, machine learning is the next thing that is expected to revolutionize the world that we live. And it's already taking place right in our height now. Everywhere you go, machine learning. Everywhere you go, machine learning. To the extent sometimes big organization or government, they call for proposal and they insist that the proposal must have machine learning as part of the component. So everything is moving towards machine learning, because imagine a system that you can train and can learn from data set and can also update itself with time. It means in medical, we can get a lot of advantage, as we're going to discuss also later. So that is machine learning that we want to look at and how we can use it in our own biomedical or public health sphere of specialization. So machine learning is the next internet. So machine learning is the hot new things. So machine learning is going to result in a real revolution and also for that quote. However, this is my favorite quotation regarding machine learning because it summarizes everything. If you can imagine how internet has changed everything. See, during COVID-19, we were still going to school online. It was made possible by internet. A lot of things that have changed in our life because of internet. So the next thing that is expected to change things drastically, like internet did, is going to be machine learning. Now, so what is machine learning? So we said machine learning is actually could be defined as automating the automation. When you automate the automation, then what is automation? Automation is when you try to computerize. You have a manual system. You want to convert it to a computer-based system. That is automation. So you need a software developer to come and write it, to come to your organization, study how you are doing things, and then convert it to an automated system. That is what we call automation. For example, before, when you want to compute student CGPA, we used to use manual way of doing that, put it on the file, and then you do that. But now, today, everything is already computerized. That is what we call automation, when you convert manual system to a computerized system. Now, the idea of machine learning is now taking automation to another level. You see, the normal automation we do is usually carried out by the software developer. You need a human being, a software writer who will come and do that for you. However, machine learning is now saying, because there are a lot of challenges with automation, we want the automation to be automatic. So we want to automate the automation. That is the act of writing the program itself. We want it to be done automatically without intervention of human being. So in essence, what we are saying is that we want to get computers to program themselves. That's what machine learning is trying to do. Getting computers to program themselves. That is what we mean by automating the automation. So for several reasons, there are a lot of shortages of software development experts. Even when the experts are available, when they develop some software, sometimes problem comes along the way, maintenance become very costly, mistake can happen. But however, since computer has this unique capability, can we get them to write program for themselves? This is actually what machine learning is trying to do. So get computer to program themselves. Writing software is the bottleneck. How do you write a software for computer? Because computer always depend on human being to write software. Whatever computer we do has to be specified by human being. That's why we have the concept called garbage in, garbage out. If your programmer made mistake, then the software that goes to your computer will be mistaken, and then the outcome is also going to be wrong. So writing software now that will make computer to automatically write software for itself is really, really too difficult. A lot of effort were made in the past in software engineering to see if we can be able to present our requirement specification in a formal language or in a formal way. Can we have another software that will automatically change our requirement specification to become a working program? A lot of effort, research were put into it, but the reality is it wasn't a big success. It was challenging to do that because the cost of writing a software that will make a computer to automate itself is even becoming too costly and too cumbersome, almost impossibility. Therefore, since writing software is the bottleneck, then how do we do that? Machine learning is bringing something on the board. It said, let the data do the work. Really? Yes. This is what machine learning has come to do. Data. Just give me the data, then the computer can automatically write a program for itself. And data is everywhere. Data is wasting away. You go to medical center, a lot of information about patients. Can we use this data set to generate unique programs that can support the maintenance of good health for our community? So that is machine learning for you. It is automating the automation, which means getting computers to program themselves. However, to do that, how are we going to write the software is the big challenge. Then machine learning was able to detect that we can let the data do the work for us. How does that happen? I call it a paradigm shift. It's a total shift in what we know. That is, let the data speak. See, traditional programming, this is computer solution, the one I mentioned earlier, automation. See, you write a program. This program has to be written by a software developer or software engineer. Once the program is completely written, working, then you have your data. You give your data and the program to the computer, and then using the program, computer will generate outputs that you need. This is the traditional programming that we have. What we call it automation. Give data in, the program and the computer will use program and data to generate output for you. However, machine learning is saying we are changing it. Because writing this program is not easy. It's not easy. I give an example. See, hardware keep coming out every day. New hardware, i5, i7, first generation, fifth generation, eighth generation of computer. Every day we have new hardware, but software is not coming out easily. The big giant Microsoft, sometime we write new software. They release a new edition of their Windows after spending years, maybe 2-3 years or more. And sometimes they detect that there's a big bug in the software they have just released. And they have to ask the user to either suspend using it. I remember the incident of Vista. There was a version of Windows that was released called Vista. After people started using Vista, they noticed that there was a very, very lot of big bugs, mistakes in the software. They have to ask the customer, the users, to upgrade to a new version of Windows for free. If you bought Vista, then you are made to upgrade to the newer version of Windows that has been able to fix those bugs, and you are going to upgrade it for free because the errors were so grave. That is one of the challenges facing writing program. Writing program and making it successful is not something that is easy. Therefore, machine learning is trying to bypass that idea of writing program by doing what? By saying, hey, give me data and give me output. I will generate automatic program for you. Wow. As a computer science person, to me, this is revolutionary because it's totally strange and totally unique and very unique. That is, data set is available everywhere. It's wasting away, by the way. We have a lot of data set that has been there on our hard disk that we're not making use of. Some of them on our paper. Can we just gather them, put them in Excel file? It's telling us if you can give me a data set and then you give me the output, I will generate a program that you can continue to use the program. Let me give you an example to make it hopefully clearer. Imagine you have, and we all know the challenges we are facing in the world presently, a lot of people suffering from diabetes. Imagine you have a medical center where you manage a lot of diabetes cases and new ones are coming every day. And the more challenging thing is a lot of people are even having the disease, but diagnosing them, the doctors are overwhelmed. Medical centers are overwhelmed. Sometimes in some villages, they are not even available. So what do? Machine learning say, okay, you have a lot of data set in the past. You have patients that you have treated. Some of them, you have them positive. You know, this person is confirmed to be positive. So bring the data of these people. Okay, we have the age, for example, the age of the patient, the weight of the patient, the BP of the patient, whatever information you have about the patient, just bring it out. This is what we call data. Say for patient number 1, give me all this data, BP, the age, the weight, the history of the mother of this patient, the history of the father of this patient, and all other information you can get. Give it to me. The computer will take it. And then, do you know the output of this particular patient? Yes, this patient was diagnosed of diabetes, confirmed. Okay, that patient is positive. 1, we give it to the system. We call this procedure training. We train machine learning by doing this. We are training machine learning model to be able to identify. So you have another patient, we call it the negative classes. No, this patient doesn't have diabetes, it's negative. But you give the same data about this patient, that's fine. 0, it's not diabetes. So we want to see as many patient data as you are giving all the data, you're giving all the output of that particular patient. So this patient is sick. Oh, this patient is not having diabetes. Oh, the next patient is having. You give as many as possible. This is called training. Once you train this machine learning algorithm, there's a machine learning algorithm inside here. Once you train it enough, automatically, once you are done with the data, maybe we have like 500 samples or 250 samples or 300 samples or even 150 samples. Sometimes it could be less. Once this data set you have is finished for this particular project, then the computer will generate automatically what we call a program now. Some people call it model. It could be a predictive model. So this program that will be generated by just providing data and output. You can see here, we don't need a program now. There's no programmer to write anything for you. Nothing like this nation. Just give me data, tell me the output, give me data, tell me the output. Our machine learning algorithm will generate automatically a program. The good news about this program is now you can send this program to the village. You can send it to the village, and doctors also can use it to support their decision making. So when new patients are coming to the clinic, just get their own data set similar to what you have. This is a new visit. For the first time somebody is visiting the clinic, you want to do screening for that patient, for that person. Ask all these questions, put those questions into the model, and automatically it will generate a trained outcome for you. It will predict, it said this patient is positive or this patient is negative to diabetes. Because of the training we have done here, then we are going to be able to have a model that when anybody comes across and use the model, which is now in our computer system, it could be on our mobile phone, could be online, just log in there, look at the model, give the needed parameter or information from the patient, the age, the BP, and whatever basic information, the model will check this new person visiting your clinic and will diagnose that, oh, this person is having is positive to diabetes or not. Sometimes you can send this kind of program to the village where we do have medical practitioner so that a nurse there can use this program to diagnose people and then recommend that these people need to make a follow-up in the city center where they can be able to be attended to by medical doctor or by public health officers. So this is just giving a kind of scenario example of what machine learning is bringing to the table as a health practitioner. Now, moving further, how does this happen? That is the idea of just giving data and output. How does it happen? Is it a magic? No, it's not magic. See, it is just like gardening. That is Mazran. That is when you want to plant something here, you can see very nice look. These are green vegetation. You want to plant something in your farm or around your house, you need a seed. The seed is the machine learning algorithm we've already inserted into the computer. You need a seed, which is standing for the algorithm. You need nutrients. You need to get fertilizer to make sure the land is fertile. Because if the land has no minerals, the plant cannot grow. The nutrient is the data you are providing for the computer. Then you have the gardener. It is you. You are the machine learning expert. You have experience. You know how to do the training for the system. And then, if you are able to have these seeds, nutrients, gardener, which is the person who is going to do the work for you, and plant, you are going to have the final outcome is going to be a very nice plant, like the one we're looking at, very nice, interesting to look, which is the program being generated by the machine learning procedure. So it's as simple as that. So just like you pass through the procedure to get your plant, you pass through this system to get our automatic program, and this program can then be used. And the good news is you that I'm talking to as a student of public health, you can actually be the gardener that will be in charge of your machine learning development. You can build a machine learning model within few minutes once you have your data set available. And the good news, this day we have what we call codeless AI. codeless AI. You can even develop machine learning model without writing a single program, a single code, because we have drag and drop, we have click, we have packages that you just click, load your data, build the model. There are ready-made packages you can use to build your models. For those who don't know how to program, that should not be a problem. For those who know how to write a program, that is fine. We have R languages, Python, and many other programming languages that support building machine learning models. But without programming knowledge, you can also build machine learning model and use it as you wish to solve a lot of problems. So we say machine learning is any process by which a system improves performance from experience. So a system improves its performance from experience. So give me data set. The more data set you have, the better. So there's no amount of data set that you say, oh, this is enough. It depends on the area you are working on. So machine learning is the study of algorithms that improve their performance P at some task T with experience E. So you need previous data set of people that have been confirmed to be struggling with this disease. Let's say you want to use machine learning to diagnose any disease. You need past data of people who have suffered from the disease, confirmed. And you also need people who are free of the disease, the negative class. And then the system gets trained and generate a model that you can always use later to diagnose your patient easily. So the goal of machine learning is to build computer systems that can adapt and learn from their experience. So machine learning algorithms discover the relationships between variables of a system, that is input, output, and the hidden from direct samples of the system. Now, this is what machine learning is doing. Every system has input. Then there is also output for it. So give me your inputs, which we call the data before, and then tell me the output. What is your output? You have it. There's a secret here that we don't know it. What's the relation between your input and the output? This is what machine learning is generating. We call it hypothesis function. Hypothesis function. That is the program. That's why we call it hypothesis function. Sometimes we call it program. Sometimes we call it a model. These are all the same name for the same thing. All the different name for the same thing. So once we are able to generate this H, the hidden relationship, every system has some hidden relationship that is connecting their input to the output. So once you give me your data set and you tell me the output, then machine learning has that unique capability to find out what are the unique hidden variables. What are the hidden information that you need to connect input to the output? If you are able to get that, which we call it hypothesis function, or we call it model, then it is finished. It means subsequently, when you have new patients visiting your clinic, you just need to ask them some information and then give it to the model, and the model will predict the status of your patient in front of you. So you don't need to know their output. You don't even know it already. And like I said, some of this model can be taken to villages where you don't have medical practitioners to make it easy for everybody to have access to medical information. Now, there are different paradigms of machine learning. Different paradigms of machine learning, or subfield of machine learning. So, the first one here is called the association rule. We use it in machine learning. We train it to, an example here is what we call the basket analysis. Basket analysis. This is where we study a system. It's often used for business, transaction monitoring. So we want to know, use it for recommendation system. We use it for our supermarkets and shopping malls, business analytics. For example, we have P of Y given X. What is the probability that somebody who buys X also buys Y, where X and Y are products and services? For example, probability that somebody who buys chips also buys biscuit is 0.7. It means there's a very huge, big probability. If somebody buys chips, it's likely going to buy also If you buy biscuits, you are likely going to buy chips, and it could be applicable to others. Some of our shopping malls, they use this association rule mining, call it association rule mining, to analyze their businesses and take decisions. For example, you see it every day, you might not recognize them. So you go to a shopping mall, you see that they totally change the outlook of the mall. They rearrange their products. See, because they run an association rule mining, basket analysis, they notice that everybody who purchases item A will always purchase item B. So the next sale, they will make sure that they separate A and B, because they find out that all our customers, whenever they purchase A, they always purchase B. So the next time they're going to arrange the shopping mall, they are not just wasting their time arranging the shopping malls. They already run some machine learning algorithm that shows that customers that purchase A always purchase B. So they rearrange it in such a way that next time A and B should not be together. They put A at the beginning of the mall. They put B at the end of the mall, far away from each other. Why? So when you buy A, since you always like to buy B, then you start looking for it. You'll be looking for it in the mall. So before you get to the B, where it has been changed to, you will see a lot of things on the way. Advertisement. So they want you to go around the mall, get to know some of our new products, and possibly you're going to buy them. This is one of the very popular usage of association rule mining. See? So the business owner use it to force you to go around and get to know more about what they are selling. And by so doing, you will buy some of the things you never even planned to buy before, because you say, oh, this is nice. Even if you are so disciplined, maybe the family member that follow you, your children, oh, dad, mom, look at this, it looks good. So you end up seeing a lot of things that you never planned to see. That is basket analysis for you, as an example. Sometimes, actually, if they notice there's a product that no one is buying this product for a long time, then there can be promotion sales on it. Then buy A and get C for free. Buy A and get C for free. C used to be $3 before, or why this one used to be maybe $10 or 10 Saudi Riyal. This one used to be 3 Saudi Riyal, depending on the location. So they make this one to become 1 Riyal. So they just, okay, buy A and get C for free. Instead of 10 Riyal, you're going to pay 11 Riyal. It means you are paying 1 Riyal for this item that you don't need. Basket analysis support business entities to be able to understand some of the ways to know what the customer is purchasing, what the customer does not need and what they need, and to be able to restock appropriately. This is called association rule mining. Another very popular aspect of machine learning or subfield of machine learning or machine learning paradigms is what we call supervised learning. Supervised learning. All the examples of diabetes I gave earlier falls under supervised learning. It is the most popular one that we use to solve problems for clients. You need it a lot in public health and biomedical applications. Supervised learning means you train a machine learning model under the supervision of a teacher, and that teacher is the output that you have. We have the output. This is called supervised learning. That's the example we gave us earlier. So this is an example of a supervised learning. You have your data, you have the output, and then the algorithm of machine learning get trained and then generate a program automatically. This is what we call supervised learning, and you can use it for a lot of applications. In the supervised learning, you have the input, which is the data. Now you have the input X1, X2, X3. It can be as many as possible. So X1 can be the age, X2 can be any attribute of the patient or the person. And then you have the output, Y. So these are the patient 1. This one is diabetes 1. Patient 2, this one is not diabetes. 3, this one is diabetes. You get as many as possible. The more data set you have, the better. So and then you train it, generate a model, and you can do prediction, as I've explained earlier. There are two major types of supervised learning. We have the classification and then we have the regression. In the classification, this is when your output is actually a discrete value, like this. Because this is practically like yes or no. Is this patient diabetes? No, yes, yes, no. We call it classification. It has unique discrete value that must be added, or label. We call it label. You use label. So you want to know if a student will pass an exam or not. That is yes or no. That is a classification problem. Sometimes you want to know the class of grade that the student will have. Is it A, B, C, D, E, or even F? So we said this is a multi-class problem, multi-class problem, multi-class. That is, this is a classification problem with many classes. A, B, C, D. It could be A plus, A minus, B plus, B minus, and also for that. See, this is classification for you. The second type of supervised learning is regression problem. In the regression problem, you are not going to be predicting label values, maybe 1, 0, or yes or no, or A, B, C, D, E, F. No, you are going to be predicting actual value, numbers. Numbers. For example, based on information, I want to estimate the age. I want to estimate age. It's used in forensic science, forensic investigation. When something happened, maybe a particular patient, they cannot trace this record, they don't know where it comes from, and they want to know the age of that kind of patient, to be able to know the kind of drug that can be recommended for the patient. You need to estimate the age, and there's nobody around. Maybe there's an accident victim. No family around. They don't even know where he's from. You need to know the kind of drug you can give. You need an estimation of the age of such patient. We can quickly have a machine learning model that has been developed for age estimation. Take a measurement of the length of the person, take a measurement of the carpal, the finger length, the toe length. Based on this information, we can quickly come up. There are models that have been built that can be able to estimate age based on some very simple information that can be gotten from a patient. In that case, we want to predict the age. Maybe the system will say, oh, this person is 23.5 years. So when you are predicting actual real number like this, we call it regression. That is an example. It could also be your student grade. You want to know the mark the student is going to get after the whole semester. Is it going to be 95.6? Is it going to be 99.3? What's going to be the total aggregate mark for the student? This is called regression. So when you are predicting actual values, then this is regression. When you are predicting labels, is it going to pass yes or no? Then this is classification. And sometimes the project you are doing might have both classification and regression problem. See, there could be both classification and regression problem. Let's say, for example, you want to work on stock market modeling. You see? So in the stock market, you want to know if the stock market is still going to go up or is going to go down. That is yes or no. See, that is a classification problem. But you want to know what's going to be the price of stock market for a particular company today. That is regression. You want to know the actual money, 10.25 real or whatever is the price. That is regression. So you can have a problem that is multi-stage prediction solution. So you started by predicting, will this student pass my course? Yes or no? See, we have a project. We want to, we call it EDM, educational data mining. You want to be able to predict at the beginning of the semester, we want to know students that will pass this course or not, so that we can be able to support. If any student has been identified that is likely going to fail the course, we start to give them special monitoring, tutoring, advice, how to study, so that they don't fail the exam. So machine learning can serve as interventionist system for us in this case. So in that case, first of all, it's going to pass or fail. That is yes or no. That is classification. Second stage, okay, what's going to be the actual mark is going to get finally? It's going to be 65.5 or 75 or whatever. This is regression. The same thing in medical. In medical, you want to be able to estimate quickly, okay, what is the age of this person? You have the age. Is he adult or is he a child? You quickly identify using your model. And then you want to know the amount of drug dosage that need to be given to the person. You can also do regression estimation to determine the milliliter that you are going to get. So this is called supervised learning. The difference being that you are training your system in the presence of an output. So for regression, the output is going to be numbers also. You are going to give the age, 23.5, 24.5. You have the age of many people. You use it to train the model. Once you train the model, then subsequently, you can use it to predict the age of unidentified patient in the emergency unit. This one very unique application that could be built for that. The next type of machine learning is what we call unsupervised learning. Unsupervised learning is when it's not something that a machine learning practitioner is looking for. We always want to get supervised learning because it can guarantee that you get good results always. Because you have output to train your model. But in this unsupervised learning, there's no output. Now maybe you got a client in a medical center, you have a lot of data set of patients. And this patient, you know they are diabetes patient and non-diabetes patient. These are the category there. You know for sure. However, the label where they put there, where the doctor signed to confirm that this patient is diabetes, this one is non-diabetes, that portion is gone. Maybe it's water poured on the paper and the paper got destroyed. Maybe there was fire incident and so part of that information is gone. So in essence, in unsupervised learning, we don't have this. We don't have this. We don't have the output. We only have data. We have data. The output is missing. So in machine learning, we can still do something. We try to study the data set and partition them into groups. Example here is called clustering. You can do clustering for it. So we get the data. Since you don't know who is diabetes, who is not diabetes, you don't know the classes, you don't have an output, okay, we can do something. So we try to study the data set using some algorithm, like k-means, and then we can partition it into 2 or 4. Okay, this data is having 4 group of people. Then we partition into 4. Sometimes it is only 2, we divide into 2. We study the attributes and we categorize them based on what they have. Because everybody in a group, they have some unique attributes that are closer together. Yeah. If we put data together, those people that are suffering from a particular disease, they are actually likely going to share some similar attributes. Those people who are free of those diseases, they are going to share some attributes. So in machine learning, unsupervised learning, when we don't have the output, then we try to do clustering to study it specially and then partition them accordingly. However, like I said, it's not what somebody wish for. We don't pray to have it, but when we have it, we try to solve it using unsupervised learning. Because unsupervised learning sometimes could be very challenging. You might not be able to guarantee the outcome you're going to get. Is it okay? It's not okay, because there's no data to train your system to check it out. So, but then we do sometimes use unsupervised learning as a pre-processing for our supervised activity sometimes. Now, the other one is the semi-supervised learning. This is between the supervised and unsupervised. It means you have some data that are labeled. You have some data that are labeled, small labeled data with large unlabeled data. That is, some have output, some doesn't have output, and they are put together. In that case, we use semi-supervised learning. It's like in between the two. So example also here is active learning. So where we have interactive supervised learning going on. So this is the semi-supervised learning, in between supervised and unsupervised. You have a mix of labeled data and unlabeled data. For supervised learning, the complete data set there is labeled. For this one, unsupervised learning, there's no label in the data. But for semi-supervised, some are labeled, some are unlabeled. And then we have the reinforcement learning. Reinforcement learning is another aspect of machine learning that are often used for building agent systems. So robotics benefit a lot from this. So it works by generating a learning policy. So the policy could be positive, it could be negative, it could be punishment, it could be extinction. The basic idea is the system learns from mistake. So algorithm learn to react to the environment. They are getting information and feedback from the environment. What we can compare to this in real life is reinforcement learning is like if an algorithm decides to do something, then if that thing is correct, you give it a thumb up. Yeah, this is excellent. It will continue to do the same thing. That is reinforcing what it is doing. Like a child at home, if a child does something good, you want to reinforce that behavior, you give that child a kind of compensation, a gift, so that you continue to do what he is doing. However, if a child does something that is bad, you don't reinforce it, you reinforce in the negative way. You withdraw you used to give chocolate, you not give the chocolate. To let the child realize that what you have done is not correct. So that next time you will not do it. So that's why we have different policy. We have positive, we have negative, we have punishment. Sometimes that could be punishment, sometimes extinction. The robot may have to be taken away from the multi-agent system. So when a robot does something good, we say, oh, it's okay. You give feedback. This is correct. If there's something wrong, you let it know that this is not correct, so that we avoid that decision next time. So this is the kind of training we call reinforcement learning. And then the last but not the least, which I've mentioned earlier, is deep learning, which is actually highly connected to, it's a subfield of machine learning, a kind of a type under machine learning. It has exceptional capability to undo feature extraction automatically, especially for image, videos, and text-based application. When you are working on text-based application, or images or videos, deep learning is the place to come to quickly have a call on that. It has that capability to extract imaging features without the intervention of any human being. However, when you're having normal data set, numbers, like we have been having here an example, you have them ready, numerical values, it's better to use ordinary supervised learning to work better for you in most cases. And in machine learning, we always do what I call let the data speak. Let the data speak, which means you have to compare different machine learning algorithms and see which of them is working for you. And after that, you can choose the one that is getting you better outcome. Now, so this is again to reinforce what we mentioned earlier, that the big boss, the artificial intelligence, has our subsidiary of machine learning. And then where the deep learning is the subfield of under machine learning, as you can actually see. There are relevant emerging disciplines that are connected one way or the other. So the big AI, you can see the artificial intelligence, you have the machine learning, you can see deep learning is within the machine learning, you have the deep learning, you have robots, you have knowledge-based system, NLP. These are other aspects of artificial intelligence. But the unique thing is these days, each and every one of these needs machine learning to do a better job. So that is machine learning is taking over the whole system. When people talk of artificial intelligence, they think it is all about machine learning. No, there are other aspects. But what is now happening is even other aspects need machine learning to do a greater job. Like NLP, they are very old method. Robotics, they came long time ago. Knowledge-based system came long time ago. But now, directly or indirectly, they need machine learning to perform exceptionally well. So when this is machine learning work really uniquely with data. The more data set you have, the better. Then we can have prescriptive, we can have predictive solution, descriptive solution, and also of other analytics that we can come in, especially as it relates to medical and biomedical engineering. Moving forward quickly, we mentioned to us some of the machine learning algorithms and techniques that we have used in researches. So there are so many machine learning algorithms out there, but just to let you know, very popular ones, artificial neural network, which is following the pattern of the brain to see how the brain learns, speed on that. And deep learning is actually based on neural network. So it's an advancement form of neural network. We have the decision tree, k-nearest neighbor. K-nearest neighbor is a very simple algorithm. We usually recommend for people still starting to look into them. Support vector machine, extreme learning machine, and so more other ones. Sometimes also we do hybrid. And sometimes you might need optimization techniques to support your machine learning algorithm to be able to learn appropriately well. Now we're going to move into successful application domains by our teams. Right to say that due to the shortage of time, the seminar is not enough to discuss all this, but we're going to give a reference for us. If you want to listen to some of our videos, earlier work on these algorithms and how they work, we're going to give us a reference for that. We can check it out. Which one is okay for you? How can you use it practically and in an easy way? Now, let's look at some successful application domains that have been investigated, used machine learning for in the medical fields. There are so many work that have been done, many areas have been done, but we're going to focus more on biomedical and public health solutions. So, successful application area that we often work on include the oil and gas, is it permeability prediction, PVT, nanomaterial characterization, magnetic refrigeration, that is working on alternative energy source, material science, biomedical, biomedical, and public health. A lot of work has been going on in this area. This is our concern for today. Superconductivity, membrane technology, and other areas, ignition, energy prediction, and also for the application area we can work on. Now let us look at some of the medical, biomedical, and public health predictive solutions that we actually successfully deployed. Because the topic of our talk is we want to take a clue from some of the successful applications and then see how can we benefit from them to push forward for future directions and development. So successful application related to biomedical and public health application. These are just samples. These are samples of some of our work, application related to biomedical and public health. Look at one of these. This is one of our new recent publication or proof of concept in this area. You can see this is a comprehensible machine learning based model for preemptively diagnosing multiple sclerosis using clinical data. A retrospective study in the Eastern Province of Saudi Arabia. So, published with an impact factor. It's a Q1 journal and also an impact factor is specified there. Another one is the novel ensemble-based techniques for preemptive diagnosis of rheumatoid arthritis disease in the Eastern Province of Saudi Arabia using clinical data. Very simple data set. Basic clinical data were used and we train models, we build the model and we're used to use it to estimate the unseen data set as the case may be. We also have other in this series. So, yes, the method, then we have the Alzheimer's disease. This is Alzheimer's disease. We also have another one for preemptive diagnosis of Alzheimer's disease. The idea of preemptive diagnosis is we don't wait for it to get complicated. At the very early stage where people thought that they were still fine, we try to investigate. Everybody should be able to check his own health status. Since it is not feasible for medical doctor to check everybody's health status, why don't we develop machine learning system that can be on mobile, that people can check their own health status without necessarily going to the clinic? Because the hospital will be overwhelmed if everybody have to check for the health status, even though you are okay. And a lot of chronic diseases, even though they are in the body, they don't show signs until it is late stage, unfortunately. So this is the essence of this work called preemptive diagnosis. We want to target people who thought that they are okay, but actually they already have underlying factors that are there's already some disease in their body, but it's not yet showing signs. By the time the signs comes, many people visit the clinic. By the time they check, they say, oh, it is a late stage. Then why do we wait for late stage? We can use machine learning to prevent these kind of scenarios by building models for some of these diseases. One of the work from public health practitioners also is the prediction of generalized anxiety level during COVID-19 pandemic in machine learning-based modeling approach. There are so many other works, so we cannot continue to list them. This is studying the comorbidities and risk factor for severe outcomes in COVID-19 patients in Saudi Arabia. So, and also further ones that we work on. Google Trends identifying senses of religious gathering. So apply to investigate the correlation between crowding and flu outbreak. This was to identify, is there any relationship between flu outbreak and crowding? So support vector machine for mechanomyographic signal predict neuromuscular simulation. So this is for knee extension exercise after the surgery to the nails. And also for that work that we have done, we work on it using machine learning to solve a lot of health-related problems. This one is for machine learning for the prediction of chronic kidney disease. And then we have other ones on the predicting the refractive index of oxygenated and deoxygenated hemoglobin using genetic algorithms support vector machine. So here, this is a regression-based problem, the one we mentioned. We want to predict the refractive index of oxygenated and deoxygenated hemoglobin. The medical team knows better about this, and they'll be able to know that, oh, if we have this information, that can really support us to be able to take appropriate decision, as the case may be. So there are other areas also that have been done in this area. There are so many of them. One of the very unique one we did is where we use machine learning also to preemptively diagnose schizophrenia disease. So this is really the disease of the aphelia. And also another one in this rate is the prediction model for post-operative decision-making based on neural network. You know, when medical practitioner, when you go to surgery room, we have to monitor the patient. After the surgery, sometimes this surgery can take hours. So the doctor needs to decide, where should I send the patient to? Should I send the patient to the ward for recuperation? Or should the patient go home, discharge immediately? Or should the patient be taken to ICU? You know, we need to take this very hard decision. Imagine a medical doctor who has been in the theater for several hours, and then they have to now go to the computer and start studying all the data, because as the patient was undergoing the surgery, the machine is collecting the data, the blood pressure, the oxygen flow, the oxygen level, the way it's going down and going up. Doctor need to monitor all this and see, okay, is this patient really stable to go home or to go to ICU if it's in a critical situation? Of course, the best decision always to be on the safer side is to send everybody to ICU, but we know it is not possible because the ICU has very limited capacity. So taking everybody also to the ward who can go home is also not good, because some people who want to get admission, there's no bed for them. So we need to take very effective and accurate decision. And to allow a medical doctor who has been under stress to do this is very challenging. So we came up with the kind of system here. We train a machine learning model that can aid. It's a model is to aid the post-operative decision. So the doctor just need to open the model and then try to analyze the data of the patient. The machine learning model will automatically predict this patient should be taken to the ward. Why? Because of this so explanation. It should be stable enough to go to the ward. To me, this is a game changer application that can support doctors and prevent them from making mistake in this kind of stuffs and other related medical intervention places. Sometimes you want to use a system to diagnose if a particular patient is going to survive a surgery. If a doctor knows ahead of time that a patient might not survive his surgery, then they will provide a lot of medical intervention. It doesn't mean they're not going to go for the surgery, but they'll make sure that there are life-saving people or facilities on ground. In case something go wrong, they can quickly administer the needed support. So a lot of things we can use machine learning-based modeling to support effective decision making in the health center, or as the case may be. So because of the time, we're going to these are just looking at this summarily, and some of these details also will be provided for the participant through the coordinator. Now, ongoing effort and future possibilities towards the end of our presentation. So there are a lot of ongoing effort, like preemptive diagnosis of selected chronic disease using computational intelligence techniques. It is an early warning system towards sustainable proactive medicine in KSA. The idea is that a lot of people go to the clinic, just complain, and they say, oh, they just diagnosed cancer, and it's a late stage cancer. He never had any complaint before. The question is why? And there are several cases like this. Public health people know about this. Medical practitioner knows about it. A lot of patients, they say they just started getting the pain few weeks, 2 weeks ago, 1 week ago, and they found out it's late stage. Because medically, a lot of things can be going on in the system, but human body is so unique that it takes a lot of time before the pain started coming. But underlying, there are a lot of symptoms going on in the body of the patient. But since medically, we cannot be asking everybody to come and do medical check every day, every week. It's not feasible. But with a machine learning system deployed to check basic clinical data of everybody, or even some are based on question and answers, interview question. You can diagnose if somebody is actually suffering from a chronic disease secretly before symptom. This is the idea of preemptive, diagnosing the disease before the symptoms start coming out. Because often than not, once the symptoms started coming out, the disease is always at the advanced stage. So can we diagnose it at the very early stage before the symptoms started appearing? This is the idea of this kind of possibly life-changing and intervention in the medical field. A computational intelligent predictive model for flu incidents in eastern province of Saudi Arabia. This is a decision table technique to improve biosurveillance. Biosurveillance is when we use machine learning to monitor where there's likely going to be outbreak of disease, like cholera. There may be an outbreak of cholera. Can we quickly predict it and take preventive measure? There will be an outbreak of flu next weekend, so that we can advise people, if you have to go to playing ground, make sure you go with your mask to prevent you and your family from getting flu. Just like we do predict if there's going to be rain, this is a very common thing these days. If there's going to be rain, they predict there's going to be rain, and then the necessary establishment will take decision. Should we allow the junior schools to go to school because of the risk of maybe erosion or whatever? Because there are a lot of signals that will be on the sea if there's going to be rain. So machine learning system were able to detect some of this data and build a model and be able to predict when there's likely going to be rain or not. Of course, sometimes, because this is a machine-based system, it could be true, there will be some level of error. But in most cases, they're always accurate, even though the rain might not be heavy. But then sometimes you see that the prediction comes true. So the idea of biosurveillance is, why can't we also use machine learning to also identify when there's likely going to be some, like the COVID-19 disease that came? It met everybody suddenly. Could we have actually made a kind of prediction that, oh, this kind of thing might be coming, based on data set that we can collect from the outcome fair? These are some of the very unique areas that machine learning and AI can be deployed for life-saving medical intervention. A further shift in paradigm, some of our future things to look into so that data may speak more clearly. I always say, let the data speak. So we go into hybrid and ensemble system that is trying to combine different models together to enhance the performance of our trained machine learning models. So you have a model here, another model, you combine them together. Several ones are coming up to model N, combine them to only one. This is when you have a kind of committees of machine. Several models, they are combining to take the same decision. You can see that it's going to reinforce the decision. You can get better decision while avoiding mistake. In fact, from experience, we've noticed that ensemble system has always ensured that you get the best of the best outcome. It is only a system that has guaranteed that you can ensemble. Maybe this one is getting 73% accuracy. This one is getting 83%. This one is getting 90%. You can combine them together and get 100%. This is the power of ensemble. Bring it together, several machine learning models, and then let them have a kind of a group, a committee member to take decision on the status of a particular patient or what you have to do, and then get better outcome. So important information to support the learning of machine learning, so and its application. For those who might be interested in taking it further, learning more about it, so these are some of the tools and modules you can be using. So implementation, you want to implement your machine learning in your area, medical and other areas. You can use Python if you know how to program. You can use R if you know how to program. So, but however, if you don't know how to program, you don't know programming, you don't need to know it before you can use machine learning. Machine learning is for everybody. Machine learning for all. Yeah, in big letter. Everybody can use machine learning to solve his own problem. So we can use things like Weka. You don't need to write program. There are so many other ones that just, it's a package, you just open it, install it on your machine, open it, read the help facility, or check out some videos. We're going to refer you to some of the videos you can check, how to use Weka. Within few hours, you can start modeling and building your own model that can have predictive solution for you in your own area of interest. Just get your data inside, click some file, open your file, click this. Within few minutes, you have your model built for you. So it means you know how to program, excellent, good for you, but you don't know how to program, you don't need to run away from machine learning. Weka, Orange, and some others can actually provide you with capability to do machine learning modeling without writing a single code. Furthering to this, so you can take note of this for those who might want to take it further. So there's usually a kind of a weekly machine learning section to support people, to introduce them to machine learning and how to use it. So there's always a Zoom meeting every Saturday from 9:30 to 10:30 a.m. Saudi Arabia time. So you have the meeting. You can also convert the time appropriate. This is the meeting link for those who might be interested. Also, you can check out a kind of YouTube channel with a lot of videos that can guide you in different application areas, how you can deploy, how you can plan, and making it very simple as much as possible. So feel free to check it out and then do share with your friend and interested person. Finally, towards the end of our presentation, we look into challenges, future trends, and the ethical issues related to machine learning application in health and biomedical related fields. First, on the challenges. There are a lot of challenges in using machine learning in solving public health and biomedical, medical related applications. One of the challenges is the heterogeneous nature of patient healthcare records in formats and location. You see, most of the application, you have clinical data. You know, there are different types of data. We have the image-based data like X-ray. So we have a lot of data that can actually give us good information about patient. So we have heterogeneous nature of patient data. Personally, it's not possible to bring all of them together to benefit from them. It's either you see somebody using X-ray, another one is using imaging, maybe another imaging technology. We are using clinical data, another type of data set. But can we have all this data merged together? Wow, that's going to be a very wonderful decision-making process. But it's still a very big challenge in the healthcare sector. So where we hopefully one day will be able to have capability of bringing in different type of data set, merge them together, and use them to train a machine learning algorithm. That's going to be really a big game changer, but it's still a very big challenge to overcome. The health data privacy is another issue. A lot of privacy issue has to do with health, because you cannot bring out data about patient that is sick. You have to preserve their privacy. Or that could be a big legal issue, so making it difficult to get data sets in most cases. So we have to work on that. How can we? The good thing about machine learning is machine learning data set we need anonymous data. Anonymous data. That is data that does not have any information that you can use to trace the patient. It means when you want to get data from the clinic, just request that they should remove the name, the record number. You don't want anything that can identify the patient, because you don't need to meet the patient before you can build your model as a machine learning practitioner. So we want anonymized data as much as possible. Hopefully this can resolve the health data privacy concern. Also, understanding and cooperation issue between the health professional and the machine learning researcher is also very big issue. See, sometimes the machine learning procedure need to shake tables. That is, it needs to explore strange procedure different to what is well established in the health professions. Sometimes when we want to diagnose a particular patient, we are used to checking 1, 2, 3, some symptoms in the body of the patient. However, with massive data set these days, there are lots of data that characteristics we don't pay attention to in the past, but they are proving to be more important than what we were checking before. Because we should realize the fact that things are changing. The food we are eating is now totally different from what our father used to eat because of the genetically modified food, hybridization of foods. So we have to be aware that a lot of things have changed. But with machine learning and data mining, we may be able to detect new characteristics that we need to focus more attention to in patients. This often leads to misunderstanding between the machine learning researchers and the medical practitioners. There have to be a synergy between the two of them to be able to understand themselves and come up with what is unique that can support the medical doctor while also making it life easier for the people and the community we are taking care of in terms of health. Another challenge is the lack of enough AI or machine learning professionals. Go everywhere, you see people looking for people to teach them machine learning. There's not enough professional to develop. To develop machine learning model, it's not easy to get the end user, either because people are not aware of it. So get to anywhere, a lot of people are looking for machine learning expert engineers, but they are actually not available. So a lot has to be done in this respect. There's some challenges we are facing. Difficulty in a lot of life-saving intervention that could be done from machine learning point of view, but you need a lot of machine learning practitioners to be able to implement these systems. Difficulty in getting medical-related data set is another area of challenge that we are still facing. You request for data set, it takes a lot of time before finally you get the IRB, the approval, and finally getting the data out. And then the future trend to look out for is the ensemble or hybrid model proliferation towards improved machine learning predictive solution. We want to look into better way of letting the data speak. Representation learning to continue rise of deep learning approaches, especially for image and video-oriented solutions. The need for unified healthcare data analysis framework. So irrespective of the format like nodes, MRI, CT scan, and also of others, can we bring them together to jointly use them to train our model? That is going to be very, very wonderful and unique. Of course, the rise of codeless AI is a future trend that we are actually hoping to look into. This is codeless AI. This is one of the areas that actually going to be changing the future of AI, or as the case may be, that you can deploy AI, you can build AI solution without even writing a single code using the available packages that have been developed. So these are some of the things so we have to share with us for this day. So ethical, lastly, we want to tell us that ethical usage is emphasized. We emphasize the fact that when we use machine learning, we have to pay attention, and AI, we have to pay attention to the ethical usage. Machine learning is incredibly powerful and can have significant or unintended negative consequences on society through targeting, excluding, and misusing. We have to pay attention to this. Focus should be on the beneficial aspect while avoiding negative usage for machine learning. This is what I refer to as ethical predictive solution. So I promote ethical machine learning solution, and I encourage people who want to go into this area in emphasizing that we have to all look towards how we can benefit responsibly from machine learning and artificial intelligence while avoiding the negative aspect of the usage, because everything with advantage can also be abused. So we strive as much as possible to mention that we need to avoid the negative aspect while looking towards responsible and ethical utilization of machine learning and artificial intelligence. For further details of our related works, you can check out our Google Scholar, ResearchGate, and also we have our YouTube channel there to check out some of our works that hopefully can also benefit you in as you try to learn how to make use of machine learning in your various field of endeavor. So thank you very much for listening, and I wish you all the best. So